Good day and welcome to Unique Math class. Today, we're looking at indices as a topic in mathematics and the laws that governs the operation of indices. Now, index is a concept that has to do with numbers and their powers. This is an index number 2 raised to the power 3. This 2 is known as the base, while 3 is known as the power or exponent or index. There are laws that govern these indices. Now we are going to consider the laws step by step. The first one is known as the multiplication law. If we have y raised to the power a multiplied by y to the power of b, b is equals to, since the base here is the same, we can simply add the powers. That becomes y to the power of a plus b. Now if we have, for example, 2 raised to the power 3 multiplied by 2 to the power of 2. Now, since the base here is the same, we can add the powers. That becomes 2 to the power 3 plus 2. That is equals to 2 to the power of 5. Now, this implies 2 by 2 by 2 by 2 by 2 up to 5 times. That is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Times 2, 32. So that's equal to 32. The next law is the division law. If we have y to the power of a divided by y to the power of b, now since the base is the same, we simply subtract their powers. That becomes y to the power of a minus b. Now if we have similarly 2 to the power of 3 divided by 2 to the power of 2, since the base is the same, we simply subtract their power. That becomes 2 to the power of 3 minus 2. That equals to 2 to the power of 1. That's from the division law. The next law is the power index. If we have y to the power of a all raised to the power b, this implies y to the power of a times b, which implies y to the power of a b. That's from the power index. If we have, for example, 2 to the power of 2 all raised to the power of 3, now this from the power index, we have that this equals to 2 to the power of 2 times 3, that's 6. And this implies 2 by 2 by 2 by 2 by 2 by 2. That implies 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Times 2, 32. Times 2, 64. Alright. The next law is the zero index. If we have y to the power of 0, this implies that it's equals to 1. We can prove this from the division law, which if we have example 2 to the power of 3 divided by 2 to the power of 3. Now, since this is the same, so this implies that this can cancel this, and that equals to 1. So this proves that any number to the power of 0 is equals to 1. The next law is known as the negative index. If we have y to the power of negative 1, this implies 1 all over y. If we have, for example, 2 raised to the power of minus 3, this simply implies this equals to 1 all over 2 raised to the power of 3. That becomes 1 all over 2 times 2 times 2. That becomes 1 all over 2 times 2, 4. 4 times 2, 8. 1 over 8. That from the negative index. The next law is known as the fractional index. If we have y to the power of 2, let's say a over b. Now, when we have the power being a fraction, this becomes that the numerator of the fraction becomes the root of this expression. That means b root of y. While the numerator remains as the power raised to the power a. Now, if we have 8 raised to the power 2 over 3. Now, in this case, the power is a fraction. Now, when we have a fraction of the power, the numerator becomes the root of the expression. That becomes equals to, the 3 here becomes the root. That's the cube root of this expression. That is 8. The power here becomes the numerator. That's 8 squared. Alright, so this equals to the cube root of A squared implies 8 times 8. That is equals to cube root of 8 times 8 is 64. 64 here is the same thing as saying 64 is the same thing as saying 4 by 4 by 4. That's 4 times 4 is 16. 16 times 4 is 64. So this is the same thing as 64. Now, if we have this becomes the cube root of 4 times, from the first law, we add their powers, 1 plus 1 plus 1. That's 4 cube. So at this point, the cube root here cancels the cube. Now the result is equals to 4. That's from the 6th rule of indices. The next rule to be considered is when we have base, let's say y raised to the power of a equals to y raised to the power of b, when the base is the same. So at this point, this implies that the powers become the same. That is to say, a is equals to b. Since the base here is the same, we simply take that the power becomes the same. If we have 2 raised power, let's say 3y equals to 2 raised power, let's say 4, and you're asked to solve this, this becomes that since the base is the same, we can simply equate the powers from the last law. That becomes 3y equals to 4, and that becomes that y equals to 4 over 3 from the index of the same base.